Okay, the remaining part of 4.4 deals with product and quotient of two complex numbers. This is going to be using the trigonometric form. And this actually becomes very easy given some of the identities that we had. So we discussed earlier in the chapter about how to manipulate sine and cosine when we have different angles inside and how to break them up. And instead of just going through the identities, you can certainly prove this on your own. But we'll use these formulas here to convert. And again, so we have this z with a subscript 1 and z with a subscript 2. So these are two different complex numbers, right? And so when we multiply them together, our formula is just you take the r value of each one, multiply them together, and then you combine the uh, cosine of each of the two different angles and the sine of each of the two different angles. So let's do a couple problems here. So this one is number 41 from chapter 4.1. I don't want that anymore. So this is number 41. And this is on page 340. And the next question will actually be on 341. But anyway, let's do 41. They give us this. This one over here is Z1, and I'll draw Z2 here. And let's do it up here instead. Need a little bit more room, and I want to keep our formulas here so we can reference them. So we'll scroll down a little bit to give us a little bit more room, but that'll still keep that in view. All right, so our R1 is 2, our R2 is 6. So this is again Z1 times Z2. That equals that. And so we multiply the two r's together, so that's 2 times 6. And then we take the cosine of each of the individual angles, so pi by 4 and then pi by 12. And we add that to the sine or I sine of those same two angles. All right, so really there's just one more step. I'm not going to leave it as cosine of pi by 4 plus pi by 12. I'm going to convert that, and I'm not going to leave the 2 times 6. So you should really clean this up. You shouldn't just leave them like this. So we're going to end up with 12, and pi by 4 is really 3 pi by 12. So it's 4 pi by 12, which reduces to pi by 3. And also pi by 3. So now we have a value in trigonometric form that is a complex number. And we could convert this to standard form if we needed to. We don't have to right now. I could certainly ask you to do that, and we could calculate the cosine of pi by 3 and the sine of pi by 3 with relative ease using our unit circle. All right, so let's do one with the quotient. So I'll write it down and I'll scroll back up as needed. So we're going to do a Z1 over Z2, but not for this one. Let's do problem number 47. And they give us this. Now we don't have to calculate 50 cosine of 50 degrees at all. We're not doing that. We're not going to convert it to a standard form at all. The other part is 9 and then cosine and sine of 20. Okay, so let's scroll up. So now instead of adding them, we're subtracting the different angles. Subtracting instead of adding. And instead of multiplying, we are dividing. That's it. That's the difference between the two. So let's go down and take care of that. Okay. So we can convert 3/9 to 1/3. And then we've got the cosine of 50 degrees minus 20 degrees plus I sine of the same 50 minus 20, which leaves us with 1/3 and then 30 degrees for each of them. So, and again, this is something that we could easily change to standard form if required. I'm not going to do it for this given problem. All right, so that should conclude the topics from section 4.4, and I will continue with section 4.5 in the next video.